So if I told you there was a seed sitting in your kitchen right now that turns into cyanide the moment it hits your stomach, you'd probably, you'd probably call poison control.
Yeah, absolutely you would.
But you actually likely have it right there on your counter, just hiding inside a very common summer snack.
Right. So we are looking at this really fascinating stack of research today. It's a comprehensive A to Z guide on Prunus armeniaca, which, is better known to most of us as the apricot.
Yeah, and our mission today for this deep dive is to figure out how this little fruit, which originated in Central Asia, but is now heavily cultivated in Turkey, specifically in the Malatya region, is actually this massive dual-purpose powerhouse.
Exactly. It is part nutritional marvel and, surprisingly, part hardcore industrial resource.
Okay, let's unpack this. Because before we look at how we process the fruit on an industrial scale, we really have to understand its raw biological blueprint, right?
Yeah, you have to start there because a fresh apricot is just wildly efficient. I mean, it's only 48 calories per 100 grams, mostly because it's like 86% water.
Wow, 86%.
Yeah, but even with all that water, it's still loaded with beta-carotene, vitamin C, E and K, and just a massive dose of potassium.
So it's essentially a nature-made water balloon packed with a crushed-up multivitamin.
That is a perfect way to describe it. And those nutrients, they function in highly targeted ways. Like, take lutein, for example, which is what gives the flesh its color.
Right, the orange color.
Yeah, it doesn't just float around your body. It physically migrates to the retina of your eye. And there, it acts almost like an internal pair of sunglasses.
Wait, really? It just filters light?
It does. It filters out damaging blue light to prevent night blindness. So it is actively shielding the eye mechanically.
That is wild.
And the potassium is just as active. You know how your muscles contract using electrical signals? Well, potassium manages the electrolyte fluid that carries those signals.
Okay, so if you're low on it, the signals just misfire.
Exactly. They misfire and your muscle seizes up into a cramp. But the apricot floods your system with the exact mineral needed to keep those currents flowing smoothly, which, as a bonus, also relaxes your blood vessels to lower your blood pressure.
Right, but here's where I actually have to push back on the whole healthy snack reputation. Because let's be honest, almost nobody is eating them fresh. We mostly just see them dehydrated in a bag.
That is very true.
And when you pull 86% of the water out of that biological blueprint, you aren't just shrinking it, you are fundamentally altering the chemistry. Honestly, it feels like dried fruit is kind of a nutritional trap.
Well, it's definitely a massive shift in concentration because you lose the water volume that normally paces out your digestion.
Right, the water slows it down.
Exactly. So while you do get denser fiber and iron, the natural sugars and the potassium levels just skyrocket per serving.
Which means if you have, say, kidney issues, eating a handful of dried apricots isn't just a snack. It's a medical hazard at that point.
It really is.
Yeah.
Because compromised kidneys literally cannot filter that sudden massive influx of potassium out of the blood. It can trigger severe cardiac issues.
Oh, wow.
And even for a healthy person, dropping a concentrated bomb of dense fiber and sugar into your gut is going to overwhelm your digestive enzymes. That leads to some pretty intense gastric distress.
Yeah, nobody wants that. But okay, stomach ache is bad, but it is nothing compared to what is inside the pit. Because this is that danger we talked about up top. The bitter apricot kernel contains this compound called amygdalin.
Right. And amygdalin itself isn't technically the poison, but when you chew that seed and it mixes with specific digestive enzymes in the human gut, a chemical reaction happens.
It snips it apart, right?
Exactly. It snips the amygdalin molecule apart. And one of the direct byproducts of that snip is hydrogen cyanide.
So your own digestion basically weaponizes it, and that causes dizziness, respiratory failure, or, even worse.
Yes, it is highly, highly toxic.
Which brings up a logistical nightmare, because if the core of the fruit is a literal poison pill, how are we cultivating this on a massive global scale without just astronomical waste?
Well, the industry has engineered ways to isolate and utilize every single fraction of the plant. They put the toxic or hard parts through industrial extraction.
So they actually use the toxic parts.
They do. The kernel oil, once it's separated from those dangerous compounds, is highly stable and easily absorbed by human skin.
Oh, so that's why it completely dominates the cosmetic aisle. It's the base for all those high-end lip balms and moisturizers.
You got it. And the hard outer shell of that pit,
Yeah.
the part you definitely cannot eat.
Yeah, what happens to that?
The agricultural sector grinds it into organic fertilizer, or they actually use it for biomass fuel.
Wait, just to define that for a second, biomass fuel just means burning biological matter instead of fossil fuels for energy?
Yes, so instead of burning coal to heat a facility, they incinerate these dense, dry apricot shells to generate industrial power.
That is insane. The exact same fruit that you mash up to feed a toddler is actively being burned in industrial furnaces to generate electricity. That is just staggering utility.
It is a total masterclass in zero-waste agriculture. The key is really just respecting the dosages.
Right, finding the sweet spot.
Yeah, for human consumption, the sweet spot to get all those eye and heart benefits without the gut distress is about 2 to 4 fresh apricots a day, or strictly 3 to 6 dried ones.
Okay, so 2 to 4 fresh or 3 to 6 dried. Got it. So we've cracked the code on using the flesh for nutrition, the oil for cosmetics, and the shells for energy.
We really have.
But it makes you think about the sheer timeline of human trial and error. I mean, before we had biochemical labs to tell us how to extract cyanide safely or how to turn shells into electricity, how many generations of our ancestors had to suffer the consequences of eating the wrong part of this plant before we perfected the process?
Yeah, that is a wild thought to leave on.
It really is. Definitely something for you to consider the next time you pop open a bag of trail mix.